Hey all, so in this video we're going to look at the solution for practice question 7.2. So the question goes, the thrust F, so thrust is a force, of a propeller depends upon its diameter, the speed of advance, the revolution per second, the fluid density and viscosity. So we have to show that this thrust can be expressed by the following equation. Okay, so let's understand the problem. A propeller, of course, has a thrust force, and that force depends on the size of the propeller. Okay, that's the diameter, the speed of advance. So while it is having a thrust, it also has a speed in the direction of the propeller. Okay, revolution per second, how fast it's rotating, the density of the fluid that it is currently moving in, and the viscosity of the fluid. Okay, so show that it can be expressed by this equation. So you should know that this equation is already the dimensionless form. So we have our pi 1, pi 2 and pi 3 right here. So we have to prove that we can achieve this dimensionless equation. Okay, so it's basically the same steps as you did previously, except that now you have the final answer already given. So if you don't get this, that means you still haven't solved it correctly yet. Okay, so the steps are the same. The first step, we write down the equation from all the parameters that we have. So thrust is the dependent parameter here. It's a function of diameter, speed, revolution, fluid density and fluid viscosity. Okay, so here you have 1, 2, 3, 4, 5, 6. Therefore, n equals to 6. Okay, the next step is to determine how many units are here. To determine J, we need to figure out one by one what the primary dimensions are for each of these parameters. So construct a table and write all the parameters here. So here we have F, D, V, N, density and mu. Okay, after that you write all the primary dimensions next to it. Okay, so here for force, of course we know it's kilograms meter per second square. Diameter is length, velocity is length over time, revolution per second. Okay, so this is 1 over time because revolution does not really have a dimension, just like radians. And then density is of course mass over cubic length, and dynamic viscosity is mass over LT, kilograms per meter second. Okay, so after this we check first how many primary dimensions are here. So there's mass, length and time, so that's 3 primary dimensions. So we go back here and we write 3. So we have 3 primary dimensions. Okay, so the next step is we calculate the number of pi's that we are expecting. So from n and j, we can determine that by calculating the number of k. So this is n minus j equals to 6 minus 3 equals to 3. So you are expecting pi 1, pi 2 and pi 3. So of course, based on the given expression, we have proven that we will get pi 1, pi 2 and pi 3. Okay, so next we proceed with the step-by-step method, which is basically this. Okay, so we have the table. Now the first thing that you can get rid of here, I think most obvious, will be length. So let's get rid of length. And to do that, of course, we use diameter. Okay, so the first one is F over D. and then you'll be left with mass over cubic square time, and then this will be no longer, this will be velocity over length, over time, so this will be 1 over t. That's velocity over diameter, and the dimension is 1 over t. Here we don't do anything because there's no length dimension here, so you can just write it again, okay, without manipulating it. Here, of course, we want to get rid of L cube, so you have to multiply this whole thing by L cube. That means you have to cube the diameter here, so it will be rho d cube. Then here you'll be left with mass. Okay, and here it should be, we want to get rid of 1 over L, so multiply by length, that means multiply by diameter, mu d. So you'll get the dimension is mu over t. Okay, so that's the first step. The next step is you can actually get rid of either m or time. So I choose to use to get rid of m first. Okay, so here we're getting rid of m. So for the first one, of course, we have to divide by m. That means we have to divide this whole equation by this. Okay, so F over D divide by rho D cube. So you will have force over rho D to the power of 4. This will be 1 over square time. Nothing happens here. Here is untouched. 1 over t. Here also is untouched. 1 over t. And this will divide by itself, so it will no longer exist. And this also you are dividing by rho d cube. So mu d divide by rho d cube. So you'll have mu over rho d squared. Alright, and this will have 1 over t. So finally we want to divide by t, or rather we want to get rid of t. Okay, so look at the final answer. So these are the expressions that you are hoping to get. This is your pi 1, pi 2, pi 3. So you can actually select the parameter. You can't select the first one, but you have 3 options here, and you can select, you need to select the one that will give you this exact terms. Okay, so let's check what are the repeating parameters here. Let's say we were to choose n. Okay, we were to choose 1 over t. It sounds simple because it's just n. But if you chose n, then n would be appearing in all these other parameters, right? N would appear here, n would appear here, and here. So let's look at your answer here. Is n appearing everywhere? So here there's no n. Force over rho v squared d squared, no n. In the pi 2, mu over rho vd, also there's no n. In the third one, dn over v. So n is only in one of these terms. That means n is not the repeating variable. So we don't choose n. Okay, and for the purpose of checking, I want to check this one first. Okay, mu over rho d squared. So you're expecting all of these terms, mu rho d squared, to appear. Okay, so let's check here. There's no mu. Check here, there's 1 mu. Okay, and here there's no mu. That means this also is not the repeating variable. So this is no. So you're only left with v over d. So just to check, see if v and d appears in the final answer. So here, yes, we have v and d. Pi 2, we have v and d. Pi 3, we have v and d. So this is definitely the one that is used to manipulate the other variables to be dimensionless. Okay, so let's work out the first one. we have a t square here. That means we need to multiply this whole term by a t square. V over d is 1 over t. Therefore, we need to inverse and square this. So it will be d squared over v squared. Okay, so if you can work that out on the side. Okay, for example, like this, you need to multiply with t squared. So we have 1 over t here, so times d squared over v squared. So this will give you d to the power of 2, v to the power of 2. Check that we have the answer. Force over rho v squared d squared. Okay, that means you have gotten the right answer. So I'm just going to follow how it's written here. This will be dimensionless. Okay, this is no longer there. So for the next one, this one will divide by itself, so it will not be there. For n, you want to get rid of t, so you have to multiply with t. That means it will be n times d over v. Check n times d over v. So we have that. I'm just going to write this in the same way, dn over v dimensionless. Okay, this is no longer there. And this one also, we do the same thing, times d over v. So that will be mu over rho. Just now we had a d at the top, d over d squared. You have a d here, v. This will again be dimensionless. So here you have your final answers. Check again that they are the same. So this is your pi 1. I've written here this is pi 2. So this is your pi 2. Mu over rho dv or mu over rho vd. Doesn't matter. And this is your pi 3. Okay, so that's step 4. You have gotten all the final dimensionless parameters. So we all, of course, have a step 5. So don't miss this step. You need to write down the relation. So we have to write it in the equation form. Okay, pi 1 is a function of pi 2 and pi 3. And then you write again, and just to repeat this. So normally we don't have this final answer given. But since it's given, don't take it for granted. Just write it anyway. Okay, so f over rho v squared t squared is a function of mu over rho vd dn over v. You can replace this with Reynolds number, because Reynolds number is rho vd over mu. I've said this before, and I'm going to keep reminding you of this. Alright, otherwise you can just leave it as this answer.